Hello, everybody. Welcome to our next stream. My name is Attila Toth. I'm a developer advocate at Timescale. And this is actually the second episode of the Stocks and Crypto SQL show, which is about, as the title suggests, about stocks and crypto data and how to work with stocks and crypto data within Timescale DB. Now, this specific episode is really exciting for me because we are going to continue the journey to analyze NFT transactions and try to better understand NFT transactions, specifically NFT sales. So let me get started. I will share my screen. Before I get into this, if you haven't watched the previous stream that I did last week, the recording is available on YouTube. That stream talks about creating a schema, designing a schema to store NFT transactions within TimescaleDB. And in this stream, we are going to build on top of that. So we already have the schema that we have created in the last stream, and we already have a lot of data, NFT transactions data ingested in TimescaleDB, and we are going to analyze the data set. If you're watching the recording, there are links in the description that lead you to the tutorial, to a GitHub repo where you can grab all the code that we use here. So let's get started. So what I'm planning for today, I will quickly tell a little bit about the data set that we are using. Then I will show you a very important step, how to optimize your query speed with continuous aggregates, which is a very important step if you want to make fast queries and you want to query aggregations regularly, maybe because you want to show or maybe you want to display the data using a dashboard like Grafana or Superset or Redash or some other dashboard tool. And so it's very important to make sure that those dashboards fast, and continuous aggregates can help with that. Then we will run some analytical queries, both that just Postgres, but also queries that are using TimescaleDB specific functionality. And we are trying to get some insights into NFT transactions, insights about NFT transactions. And then finally, I will show you some next steps if you want to get started yourself analyzing NFT transactions, what you can do next, and some useful resources. All right, so about the data set that we will work with. So what this data set includes is basically it's a data set of successful sale transactions from OpenSea. So it only includes successful sale transactions. And I'm using the OpenSea API. I created a Python wrapper library, which you can pip install OpenSea API, which helps you ingest data from OpenSea. How you can get it, meaning how you can get this data set, you can just go to this link, tsdb.co/nft NFT starter kit. Let me quickly show you what you will see if you go to this link. So this link will lead you to the analyze non-fungible token sales data page in the Timescale documentation. And it basically gives you a step-by-step process how you can design the schema, how you can ingest NFT data, and how you can query this data set. And it goes into a lot of detail. It shows you all the data fields. It shows you a lot more queries that I will have time to show today. So this is a really good resource to get started. Also, if you want to grab the code which this tutorial is based on, the code is available on GitHub, Timescale/NFT starter kit, or the short link is tsdb.co/nft starter kit GitHub. And this GitHub repository contains every single SQL script, the ingestion code, the Python script. It also has pre-built dashboards in Grafana and Superset. So this is a really good starting point for you if you want to get started with NFTs. analyzing NFTs. Alrighty, so let me go back to the presentation. Yeah, so the repo contains the schema and other resources as well. And now let's have a look inside the database. What kind of data set we are working with currently. So just a few. Let's run just a few count queries to see the amount of data that we currently have. So if I run this select star from approximate row count and then assets, which is the table name, it will give us an estimation regarding how many rows the assets table have. The assets table contains the basically the NFTs. We dig deeper in the previous stream regarding the data fields and different data types in the schema. But if I run this, what we see is that we have more than, let me make this bigger a little bit. So we have more than 4 million NFTs in the database currently. And these are all NFTs that were part of at least one sale transaction. Then if I run the other approximate row count query for the collections table, that returns less than 80,000. So this is how many collections we have in the collections table, or how many rows we have in the collections table. Then if I run the next one for accounts, we have almost a million accounts. These accounts are accounts that have been part of at least one sale transaction on OpenSea, either as a seller or buyer. Now let's have a look at the NFT sales new table, which contains the actual time series data, the sale transactions. So if I run this query returns the number of rows in the database, and also the basically the time range of the database, which says that we have data between the 1st of January 2021 and the 16th of November 2021. So pretty much all transactions from the past, from this year. All right, now if we want to dig deeper on the timescale specific side, we can see the number of chunks because how TimescaleDB works, basically it creates chunks. So even though you're just querying one table, NFT sales new in our case, in what TimescaleDB do is that it partitions this one table into multiple smaller chunks based on the time column. And with this query, we can see the number of chunks that are associated with the NFT sales new table. So if you run this, we see that we have 44 chunks for this table. And if we want to see the specific chunks, we can also do that by running this command. This will also return the time ranges for each chunk, which is interesting because if I go right here, you can see the range start and the range end columns. And basically the range start indicates that in that specific chunk, the data that is stored in the chunk is between in the first, like in this row, in this example, that chunk has data between the 7th of October and the 14th of October. And if you have a better look, you can see that these time ranges are always 1 week apart. And it is because the default time range or the default time interval used for these chunks is 7 days. So that's why you have 7 days chunks. All right, now let's run maybe 2 more quick queries to get more familiar with the database. So let's run this query, which will return the different payment symbols that were used in transactions ordered by count. So what this shows is that most of the transactions, more than 5.5 million transactions, used Ether, ETH, as their payment symbol. Then the secondary indicates that for a lot of transactions there is no payment symbol. This could be because, for example, um, I'm not entirely sure, but as I know, the OpenSea platform, at least the API, so the OpenSea API returns null if if uh, if something like Polygon was used for the transaction. So if it happened on the Polygon blockchain, there won't be any payment symbol in the API. At least that was my experience. But we also have other payment symbols, like, for example, this one is wrapped Ether, and we have all other um, less used payment symbols. And then another quick query: auction types. You can have transactions that were part of an auction, but if I run this query, you can see that most of the transactions actually don't have any auction types, which means that they were not part of an auction. But the ones that were sold as part of an auction, they use the auction type called Dutch. All right. So now that we are more familiar with the data set, hopefully, let me talk a little bit about how you can optimize queries with TimescaleDB, and specifically continuous aggregates, and why it might be useful. But before I do that, if you're not familiar with continuous aggregates, I just wanted to talk maybe a couple of minutes about continuous aggregates, because this is one of the most useful and most used features of TimescaleDB. So basically, continuous aggregates is materials view for time series data. So it enables you to store um, um, to basically store and query time series data more efficiently. And the main difference between continuous aggregates and the materials view is that unlike materials views, where you can, when you update the materials view, maybe you just want to update a small portion of the data, maybe just want to update the last 1 week of data, or the last day or hour of data. You still need to basically recreate the whole materials view from scratch, which can take a lot of resources. But with continuous aggregates, what you can do, you can basically refresh the materials view, or the let's call it continuous aggregate, every single hour or every single day or every single week, and you can specify a specific time window to be refreshed. And so this way, the materials view won't be dropped and recreated from scratch. Only um, the only part that will change is the time window that you specify to get updated. So this way, it's more efficient. And you can set refresh policies, which will automatically refresh data, as I said, every single day or every hour or every week, or depends on your requirements. Continuous aggregate also has an interesting feature called real-time aggregates, which is turned on by default. And what this enables is that there might be some data that is not materialized yet. Let's say if you run a refresh policy every single day, but then you have data coming in during the day, and then if you make a query during the day, the data from the day won't be materialized, but that doesn't mean that you won't be able to get it from the continuous aggregate, because real-time aggregates give you the data from both the actual materialized table and also the underlying hyper table, which has the most recent data. And I might have said it, but continuous aggregates help you make your queries faster, especially if it's a long range query which aggregates data. All right, so that was it about continuous aggregates. Now let's see how it relates to our NFT dataset, and specifically how you can create a continuous aggregate for NFT collections, for example, because that might be useful if you want to analyze NFT collections, which we will focus on in this stream and in the queries part of the stream. So this is how you create a continuous aggregate. As you can see, we are using the create materialized command with TimescaleDB continuous, and then you have the your select statement that you want to use. In this example, we are creating a continuous aggregate called collections daily, which has the collection ID column. It has a time bucket column, which is you need to include a time bucket column in your continuous aggregates, and it will create 1 day buckets. And then we have 3 columns, which include aggregated data for the total price. In this case, it will return the average, the max, and the min price of the collection. And we are grouping by collection ID and bucket. So this is a very simple example. We will create a continuous aggregate, something similar to this in a few minutes, a little bit more complicated and with some more columns. But I also wanted to mention some limitations of continuous aggregates. So for example, you cannot use window functions when you create a continuous aggregate. You cannot do joins when you create the continuous aggregate, but you can join the continuous aggregate after you have already created it, which is sufficient in many cases. And currently, you cannot create a continuous aggregate on top of another continuous aggregate. And I also wanted to mention one more limitation, which is actually not a limitation anymore, which is multi-node support. So since the launch of TimescaleDB 2.0 from the end of October, TimescaleDB supports multi-node. TimescaleDB continuous aggregates support multi-node, which means that you can create continuous aggregates over distributed hypertables, which is a very important feature. Many users requested this feature, and if you are using TimescaleDB, but you want to, or if you're considering to switch to multi-node to be able to scale your database, but this limitation held you back because you are using continuous aggregates. This is not a limitation anymore, so you can use continuous aggregates over distributed hypertables. All right, and just one final slide about querying continuous aggregates. So it has full SQL support. So once you have the continuous aggregates created, you can do anything that SQL can do. You get the query planner benefits because the underlying table, the underlying continuous aggregates table is actually a hyper table, and it saves computational resources on time bucket queries. All right, now let's jump into the actual part where we run queries and analyze NFT transactions. So in dbeaver, let's see some interesting queries. So I wanted to run this script at the beginning, but let's run it now, just to see an example of the NFT sales new table, which contains the transactions. So as you can see, we have a lot of different fields. We have an ID column, which is just a unique identifier. We have time, obviously. We have asset ID, collection ID, auction type, which is null in most cases. We have contract address, quantity, total price, account columns. So we have a lot of interesting data fields. Now let's create something interesting. First, we will create queries without using continuous aggregates. And then we will create the continuous aggregate. We will create the continuous aggregate as an example and use the continuous aggregate to create more queries. So first, let's create um, a query which basically will be very good to display a time series chart, and it will show the total daily ether volume of a given collection. And in this example, as you can see here, we are going to analyze the CryptoKitties collection, which is one of the most popular collections in the NFT world. So if I run this query, this is fairly quick. This was actually instant, even though we have a lot of data records. But it was instant because if you look at the previous stream, we put an index on both the payment symbol column and the slug. And those indexes make this query really fast. And with this table, you can create a time chart, a time series chart, and it will display either the total volume of the collection, in our case, CryptoKitties. So, for example, on the 14th of November, there was 70 transactions that involved CryptoKitties, and with a total ether volume of more than 2. And we also have the count NFTs column, which is basically indicates how many individual NFTs were sold. So, for example, in this case, on the 14th, we had 70 sales, but only 69 of those were individual NFTs or assets. All right, now let's have another query which will return the most expensive CryptoKitties NFT sold in each week. So we are creating a time bucket, which is a TimescaleDB hyperfunction. We are creating a time bucket for each week, and we are finding the CryptoKitties NFT which has the highest sale price. And in this query, we are also using the last hyper function, and we are also joining the assets and the collection tables. So if I run this query, this was fairly quick as well. What we see here is first of all the bucket. So we have the bucket. We have the price paid column, which is just basically the max total price aggregation. We have the name of the asset. And then we also have the URL, the OpenSea URL, which we can also look up. So for example, if I maybe want to look up founder cat number 40 and see the OpenSea page, we can also do that. And if you scroll down on the OpenSea page, you can see the actual sale transactions that happened, and this is probably what is actually in the database from OpenSea. All right, so that's one interesting query because it involves joins and multiple hyperfunctions. Now let's have a look at another query which will actually create a continuous aggregate. So this is what I was talking about previously, and now we will see some queries that require continuous aggregates to optimize the query speed. So as you were able to see on the slide, we use create materials view. In this example, it's going to be called collections daily new, and we are selecting collection ID. We are creating a 1 day time bucket, so we're going to have one row per day per collection. And then we are using two hyperfunctions to calculate the mean and the median prices. And it's the percentile egg function, which you can look up in the TimescaleDB documentation. And we are also displaying the volume using the count star. And we are also summing the total price to display the volume ether. And as previously, we used the last hyperfunction to actually display the most expensive NFT ID. This one is also interesting because using the last function is capable to use not just the time column, but any other column. In this case, we're using the total price column to order by and return the last value, which in our case will return the the highest price and the most expensive NFT ID. All right, so let's run this query. This is creating the continuous aggregate. As you can see, this is still executing the query because currently we are actually materializing a lot of data, materializing the aggregates. So now that it's done, let's try something interesting. So we have the select statement here. So let's just run the select statement without the creating the continuous aggregates. So if you run this will take a little while. So it's currently running, and as you can see, it's more than 7 seconds, which can be, it's not the fastest thing in the world. But now let's try to query the same exact thing using the continuous aggregate that we just created. And in that case, we can just do select star from collections daily new, which is our continuous aggregate. So if I run this, there you go. This is instant because the data is coming from the materialized hyper table, and it's just really, really fast. So that's why it's useful to use continuous aggregates for things like dashboards, because it's going to be really quick. Now let's run some queries on this continuous aggregate. So for example, we can create a query to return the collections with the highest volume. Let's run this query. It as you can see, it searched all the collections and returned the result ordered by the total volume. And but what we could also do is just order this table by the ether volume if we are more interested in that. So for example, one thing you can see here is that CryptoPunks has the highest volume in Ether, the cryptocurrency, but it doesn't have the highest volume when it comes to the number of NFTs sold. So that might be interesting. Now, going further, we can also create a query to display the daily number of NFT transactions for a specific collection. In this query example, we're going to use the 𝗥𝗲𝗃𝗀𝗃𝗁 collection again. So if you run this, again, it uses the collections daily new continuous aggregate, and we are joining just one table, the collections table, and obviously we use the 𝗥𝗲𝗃𝗀𝗃𝗁 slug, which is the unique identifier of the collection. So this displays the daily uh, volume of the 𝗥𝗲𝗃𝗀𝗃𝗁's NFTs, and again, this could be interesting to display on a time series chart because this is typical time series data, aggregated data. All right. We have two more queries. We have a query to display the daily number of NFT transactions comparing two collections. So in this example, we're going to compare 𝗥𝗏𝗃𝗃𝗁s with another collection that is called 𝗖𝗵𝗽𝗀𝗃. We are not going to we are going to look at the full database and not just the past 3 months, but we could also do that. But let's look at the full database. Let's use the all the data points that we have. So here we have an in where we include 𝗥𝗏𝗃𝗃𝗁s at 𝗖𝗵𝗽𝗃, and this will return again a time series table, which could be used to create a time series chart. And basically, we have the daily volume for these two collections, every single day from the past year. All right, and finally, let's return the mean and median sale prices of again 𝗥𝗏𝗃𝗃𝗁s. And again, we are using the continuous aggregate, so this query also should be fairly quick. Also, it's interesting to see that this query itself is fairly simple. So, if I go back to the actual definition of the materials view, this is a much more complex query to run, especially if you want to modify it or add to it. But with if we create the continuous aggregate, we just need to query the continuous aggregate, which makes things much more simple. Also, I mentioned that we cannot do inner join or any kind of join when we create the continuous aggregate. But as you can see here, after you have created the continuous aggregate, you can join any other Postgres table with the continuous aggregate. Like here, I'm joining the collections table. So let's run this query. This returns the mean, the bucket, the slug, which is just going to be 𝗥𝗏𝗃𝗃𝗁s, the mean price and the median price using the percentile egg hyperfunction, and this could also be a good start to create another time series chart, another time chart on your dashboard, which shows these two prices, the mean price and the median price for the 𝗥𝗏𝗃𝗃𝗁s collection. All right, so I think that that's all the queries that I had for today. Let me go back to my slides. Yes, now let's talk briefly what you can do if you want to get started, if you want to do it yourself, or if you're just interested in this whole NFT world from a data-driven perspective. So first of all, if you're watching the recording, there are links in the description. You can also learn more about TimescaleDB in the documentation, where we actually have the tutorial to complete the full NFT project that I showed you with how to create the data ingestion script, how to create the schema, how to analyze the data with a lot more queries. We have a lot more queries in the tutorial. Also, I highly suggest joining the TimescaleDB Slack community. We have more than 7,000 members, and it's a really great community to get help from other users and from Timescale team members. And you can also tweet us at TimescaleDB or my personal handle @𝗏𝗏𝗏 if you want to reach out. So I hope it was useful. I also suggest following us on Twitch because Twitch and YouTube, because we are doing 3 streams every single week. So if you're interested in learning more about TimescaleDB and how to work with TimescaleDB, YouTube and Twitch is a great. They are great platforms to learn more. All right. I hope it was interesting, and see you next week. Bye.